are in listen-only mode.
Greetings, everyone. This is Stephen Feuerstein. I am an architect with Oracle Corporation and still very excited to be able to say these words, having joined just 6 months ago. You can see my email address, my Twitter account, my blog. Check them all out for ongoing news about and information on the Oracle PLSQL language, because that's all I know. And this seminar is the first of a trio, a series sponsored by ODTUG and Oracle Technology Network, my PL/SQL by Feuerstein 2014 webinar series. So this is the first in a series of 3 regarding performance-related features. Check out my blog and the Oracle Learning Library for the first 3 webinars on best practices. The topic of my talk today is the amazing function result cache of Oracle Database 11g. So let's proceed. So I'm going to be talking about a caching mechanism that's provided to you in the 11.1 and higher release of Oracle Database. So let's first talk about caching, some of the options you've got, and then we'll focus in on the result cache. So caching is a time-honored technique for improving performance generally in the world of computer software. And what it all comes down to is that you can identify that some data doesn't change for some period of time, so it's static for a period of time. And since it's not changing in the original source, why not store that unchanging data in a location that can be accessed more quickly than going back to the source each and every time? So for example, to look at an extreme case, Oracle database data are sitting in files in the operating system. Imagine if every time you wrote a query, you actually read the data from the file. That would be ridiculously slow and cumbersome. So instead, Oracle creates the system global area, the enormous complex cache, to support the entire database instance and share information as much as possible, data that is static for some period of time. And caching happens at every level in the technology stack. You hear about application server caching, mid-tier caching, database caching. So like I say, time-honored technique. And the question is, how can we as PL/SQL developers do caching to improve the performance? Because on the one level, when you look at the SGA or you look at application server caching, you're talking about caching that's built into these components, which means they're entirely generic. They will detect as many opportunities as possible to cache, but they'll also be quite conservative because caching is a form of static representation of data. And if your data changes and the cache is out of sync, you get dirty data. And at least from an Oracle database perspective, we want to have full consistency at all times. But we can also look at ways to employ caching mechanisms in our own code so we know our application, we know how it works, and we might be able to identify some new opportunities. So there are a number of opportunities for PL/SQL developers. The 3 that I'll touch on today are deterministic functions, PGA caching using package level variables, and the function result cache. Now I'm just going to touch on the first 2, give you a sense of what they are and what kind of value you might see from them. But the bottom line is that the function result cache is the most powerful. It's the most widely applicable technique, which is probably the most important thing. If you have a technique that's only useful in 1% of all the cases, that's not nearly as great as something that's useful in 30 to 40% or whatever the case might be. So we'll take a look at the first 2 in some level of high level, and then the function result cache in a lot more detail. Now, as you may know if you've experienced any of my webinars in the past, I do like to show you code, run code during the webinar, and I like to make sure that all my code is available to you. So at any point, feel free to visit the Oracle Learning Library, oracle.com/OLL, which is a tremendous repository of free resources, videos, PowerPoints, etc. on Oracle technology. Search on, you'll find the PL/SQL Learning Library, drill down to that, and then you'll see my demo zip, and hopefully you'll see that now. Let's see, come on. So here's the PL/SQL Learning Library. There's not enough here yet. We'll be adding lots more. But here's the demo zip file that you can download. And that will contain all of the scripts that I'll be showing you today, and of course, many more besides. Okay, let's go exploring. So before I dive into the individual techniques, I want to make sure that we all have a common understanding, at least at the big picture level, of runtime memory management. So when an Oracle database is started up, an instance is started up by the DBA, Oracle grabs a big chunk of memory called the SGA, System Global Area. Now in the old days, when I first worked for Oracle back in 87 to 1992, an SGA of 20 megabytes was just incredible. Today, we have SGAs of multiple gigabytes, terabytes, I suppose, maybe soon petabytes. And essentially more and more of databases, no matter how large they are being loaded up into memory. In fact, Oracle has recently introduced in 12.1 its in-memory option, which takes caching and in-memory computation inside the database to another whole level and provides incredible boosts in performance. But that's not what we're talking about today. So Oracle grabs a chunk of memory for the SGA, and essentially the SGA contains information that potentially is shareable across multiple sessions connected to the database. So for example, there are shared cursors. Every time we execute a select statement, Oracle will check to see if somebody already executed or parsed that same select statement, and if so, we'll avoid the parse step. So Oracle builds the cache and takes advantage of that data to speed up performance in a multitude of ways, sharing as much as possible across sessions. Each session connected to Oracle, however, has some of its own memory areas. The most important of which to know about is the PGA, or Process Global Area. So essentially, whenever you run a program and that program declares variables, constants, etc., the memory for those variables comes out of the PGA for that session, and therefore there's a separate PGA for each session, so that memory is not shared across sessions but is individual to that session. So PL/SQL variables inside the PGA, data that can be shared across sessions in the SGA. That's the rough cut. There are, of course, a number of nuances and exceptions, but on a day-to-day basis, this captures the reality that you need to deal with. And you often do need to deal with it because you can actually run out of PGA memory. Okay, so summary of other caching options, that is not the function result cache. First, deterministic functions. So when you declare a function to be deterministic, then under some circumstances, the SQL engine may actually avoid unnecessary executions of that same function. In other words, if I call that function with the same parameter values multiple times within the scope of a single select statement or a single SQL statement, then the engine may avoid executing the function for each one of those calls. I'll show you an example in just a moment. And the second big caching option is PGA caching. Essentially, you save static data. So for example, the contents of a materialized view, there's really not going to change at all for a user session. You save that data, or some of it, in package variables, usually a collection. And since package variables are persistent in your session, in other words, they retain their value in between accessing the package variable, then you have a cache that is scoped per session, in other words, PGA memory. This is a very fast technique, but it also involves duplication of memory in each one of those sessions and also requires fully static data. And you have to build and maintain it manually, which is kind of a drag. Is there a better way? Absolutely. In 11.1 and higher, we'll take a look at the function result cache. First, let's just show you some of the code for these other approaches. So, heading over to SQL Developer. Here's a function called betweenstring. And this is an example of a pure or deterministic function. And what that means is that the outcome, the value returned by that function, is determined completely by the input values. As you can see, there are no side effects. I'm not running any kind of SQL statement. I'm not referencing package variables. I don't have out parameters in my function. You pass in the same three values, and you will always get the same result back. That's what a deterministic function is. And I can actually specify it. I can declare it to be deterministic by putting on the deterministic keyword. What's the advantage of doing this? Well, first of all, from a caching perspective, when I execute that function inside a select statement, then for the duration of the execution of that single SQL statement, Oracle will keep track of the calls to the function and the values I pass in. And every time I call that function, it will ask, hey, did Stephen already call this function with these three parameter values, Feuerstein 1 and 5? If so, it's quite likely that the SQL engine will avoid calling the function again. And you'll get some optimization, some caching of the data, because what's happened is that if I hadn't called it with these three values before, the engine will save the values, these three inputs, and the value that's returned for potential use next time. Now, there's no guarantee, and Oracle's algorithms for determining when and how to use the deterministic functions can vary. But basically what you should be doing is identifying functions that are deterministic, that do not have side effects. And you should declare them to be deterministic because of two things primarily. One, you're giving the compiler more information, so it might be able to do caching. If you use it in the right way, you can certainly use it in a function-based index as well. But in addition, you're self-documenting to people coming along later in your code base that they should not do things like, oh, let's select count star into n from. This is now a non-deterministic function. So what you're doing is stating in your code, don't do that sort of thing. Keep this thing free of side effects. The third advantage around declaring things to be deterministic anything is that deterministic programs are the most easy to document, but most importantly, to unit test, to automatically test. So with SQL Developer and its integrated unit testing capabilities and other tools as well, it's relatively straightforward to build comprehensive automated tests of deterministic programs. Non-deterministic programs that depend on 15 tables and who knows what else, much harder to automate testing around. So if you can identify and segregate out your deterministic logic, keep it separate from your non-deterministic code, and let your non-deterministic code call your deterministic programs, you will then be in much better shape to at least do some targeted automated testing, which, let's face it, is always a good thing. So that's the deterministic keyword. I declare my function to be deterministic. I'm telling the SQL engine, hey, if you'd like to, if you can, avoid executing the function body over and over again for the same parameter values. That's deterministic. Okay, let's take a look at PGA caching. So let's suppose that in my application, the employees table is static, never changes. And all over my application, I call the one-row function to get back the employee row for an employee ID, 100, 200, 300. And the bottom line is that this data is, number one, not changing, and people are querying the same rows over and over and over again. Now you might say, well, that's okay. I've got a primary key unique index on employee ID. It's going to be a very fast lookup. What's the problem? And the answer is sure. It is going to be quite fast. But the problem is that it could be much faster. So let's take a look at an alternative approach. In my second package, I declare another one-row function. It looks just the same as the original on the outside. So a user of the function wouldn't know the difference. Inside, however, the package body is quite different. I declare a collection that mimics the structure of the employees table and declare a variable based on that type. So there's my cache at the package level, so it persists in my session. In the initialization section of my package, I load the cache. I iterate through the rows of my employees table, and I put those records in my cache using the primary key as the index value. This is a sparse collection. I'm taking advantage of the sparse nature of associative arrays to create this structure. And then my lookup function, passing the employee ID, return the row type. My lookup function simply says, go to this location in the cache and return it. That's it. I don't go through the SQL layer over and over and over again. And this one change, moving the data into the PGA cache and accessing it directly instead of going out to the SQL layer over and over again, can yield an enormous benefit in performance. Now, given that we're focusing on the function result cache, I'm not going to spend a lot of time on this today and run the scripts, but I can show you the kind of results you should expect to see. And this is the code you can run yourself if you have the employees table set up. The database table lookup, in other words, doing a query every time, 100,000 times, 5 seconds. Using my package cache, my associative array, 0.22 seconds compared to 5 seconds. That is blistering fast, and all it is a change in our PL SQL code to essentially intercept the request for data. Intercept the request for data, and don't go to the SQL engine, go to my own copy. So PGA-based caching is incredibly fast, but you have to build it all yourself, and essentially it has to be a static set of data. It's true that there are ways to get around that restriction. You could have data that changes, you could use DBMS alert, and you could use DBMS pipe and DBMS this and that to communicate between sessions and keep your caches in sync. But frankly, it's just not worth it, especially if you're on 11.1 and higher, and hopefully you all are. So these are two excellent possibilities for caching. Good things to know about. Deterministic functions primarily you should utilize as a form of self-documentation and providing some additional information to the compiler that it might be able to use. PGA caching is a great technique to use, but it's very limited in applicability. So now, let's take a look at the function result cache. So, first of all, this cache is stored in the SGA, not in the PGA. And you might say then, well, it's going to be slow, right? The SGA is where you go when you run an SQL statement, and that's a lot slower than a PGA cache. Well, it will be slower than the PGA cache, but not so much as you'll see. The main thing is that it's shared across sessions. Every session connected to the instance can access the cache. So it scales really nicely. With the PGA cache, if you have 10, 20, 100 different sessions connected, each with their own copy of that materialized view, that can consume an awful lot of memory. Second, Oracle automatically invalidates any caches that contain potentially, possibly dirty data. So Oracle's going to take care of these caches for us. We do not have to do that ourselves, and what that means, most importantly, is that you can and should consider using this feature to retrieve data from any table that is queried more frequently than it is updated. Now obviously, with a materialized view, it's queried way more frequently than it's updated because it's never updated except when it's refreshed. But you might have a lot of other tables in which, on average, you might change the data in that table every 10 minutes, 5 minutes, maybe every hour. And in between those changes, people are querying the same rows hundreds, thousands of times. That's the scenario that you can look at for applying the function result cache, which is much looser than a PGA cache. Finally, important to know, still in Oracle 12, the function result cache feature is available only in the Enterprise Edition. Standard Edition does not include it. Having said that, you can include the function result cache syntax in your code that's running in Standard Edition file, but it won't take advantage of the feature. And there may be an advantage of doing that because, again, it's a matter of self-documenting that this is a scenario that could benefit, and if and when we do upgrade to Enterprise, we'll be able to use it. So, SGA-based storage, automatic invalidations, wide applicability, not just static data sets, but data sets that are queried much more frequently than they're updated. Let's take a closer look. How does it work? Well, pretty much the same as the deterministic function I described before. You add the result cache clause to your function's header, and this, I've got to say, is just about my favorite part of the whole feature, being that, if I could find my mouse, being that all you do is add one keyword to your function's header. That's all you have to change. Then, when a call is made to that function, Oracle takes a look at all the in-argument values, and they can only be in-argument values, and it checks its cache to say, did somebody already call this function with these input values? If so, or if there's no match, the function body is then executed, and the inputs and return data are cached, and then the return value is returned. If there is a match, which will happen more and more as more data is loaded in, the function body is not executed at all. The cache data is simply returned, and that's where you see the big boost in performance. Finally, if changes are made to a table on which that cache relies, and this is something that as of 11.2, Oracle figures out for you automatically, the cache is marked invalid and be rebuilt, or you will rebuild it, or your application will rebuild it as rows are retrieved. Oracle doesn't refresh the result cache. It simply wipes out the rows that have been accumulated. So let's take a look at some code. And again, these are the same scripts you can get in the demo zip. So here's a package FRC demo, and I have a number of array structures. This is a list of names indexed by integer, and here's a list of rows, records, indexed by integer. Now here are 3 functions, and all of them are result cache functions. And all I did was put the result cache keyword on the header in the spec, and also in the body. Now, in 11.1, with the first release of this feature, we had to tell Oracle, explicitly, we had to tell it which tables the function relies on. You no longer have to do that in 11.2. This can stay here. You can take it out, you can leave it. It will be ignored. So in 11.1, you had the responsibility of saying, oh, this function that calls a procedure, that calls a function, that calls a procedure. Here are the 16 tables that it relies on. You no longer have to do that for both static, dynamic SQL. Oracle figures it out automatically. So when I call this function, If the body is executed, I will see this line of output, and if it's not executed, I will not. And it's pretty much the same for all the others. These are just variations on a theme. So what I'm going to do is create these objects. Oops, something went wrong there. Let's see. What could it be? So did we create the table? Yes. Okay, so the table's there. Our demo, our package should be there as well. Let's just pull up my schema browser and we'll check. There's FRC demo. Let's give it a try. So I'm going to call my function 10 times. Let's turn on DBMS output. And take a look at the output. And you can see that the first time I executed the function, it executed the body of the function, returned styles. And the next 9 times it said, nope, don't need to do that. And if I set up another connection and I run the same code, you'll see just these lines. It will not say executed the body of the function. So across multiple sessions, this cache is now in place and is now being utilized for this particular function. Okay? So the first time it's called, the full body is executed. Future calls, we bypass this execution entirely and simply return the values. So that's the rough idea of how it works. So as I said before, one of my favorite aspects of this feature is the minimal impact on code. With some features that Oracle has provided over the years, for example, bulk processing, for all, bulk collect, incredibly powerful performance optimizers, and in fact I'll be addressing those features in my next webinar in 1 month. But boy, the change that you have to make to your code to implement these features, to utilize them, are pretty big, pretty stiff. Here, nope, you just put result cache on your headers. The big issue, and I'll come back to this later, is that you have to have these functions in place. If you haven't built these functions, it's going to be a lot harder to take advantage of the result cache. That's why I tell people when a new version of Oracle is released, even if you know you're not going to be on that version for, boy, a year, several years, look at the list of new features and ask yourself, are we going to use this feature? If we are going to use it, can we change the way we write our code now to prepare ourselves for it? If I were on 10G years ago and looked at the 11G new features and said, result cache, oh, wow, that is a great looking feature, I'll definitely want to use that, then I would say to myself, maybe I should stop writing select statements all over the place, and instead I should cite functions so I can easily add the keyword later on. So let's talk about the performance impact of the result cache. Again, it's stored in the SGA. So you might expect that it would be slower than a PGA-based cache. But the big difference here is that we are going to be using the SGA, but it's not going through the SQL engine. And as you're going to see with the results, that's where you see most of the overhead. So let's compare a few different ways of getting data. So here's my function, one row. And it does the usual thing. It just selects the row, returns it over and over and over again. Here's the PGA cache, a much simplified version from the first one I showed you, but it looks the same. Pass in the employee ID, return the row. In my initialization section, load everything into my cache, indexing by the primary key, return by the primary key. And then finally, I'm going to go back to my original package that has my select statement in it, and I'm going to add the result cache. And here I got a little bit fancy. I also used conditional compilation that basically gives commands to the compiler saying that if the version that you're running is 11.1, add the relies on clause, otherwise leave it out. So this is just a little hint about the way that you can use conditional compilation to make sure that it compiles differently on different versions and essentially takes advantage of whatever new features are available in whatever version is running. I will compile these 3 packages. Okay, all compiled. let's compare them in performance. So what I'm going to do is build a procedure that will exercise my code in different ways. So here's my database lookup, my 11G function result cache lookup. Here's my cache in the table in the PGA. And here's my run the query every time. Now one question is, well, how do I, I'm going to call it this last one. How do I time these? How do I compare the performance? They're all going to be super fast. So one of the things I've done is create this package called sftimer, which I think is not even necessarily installed here yet, so let's do that. And this package takes advantage of the DBMS utility getTime procedure. Let's compile. Let's compile the package body. And basically what it does is keep track of the start time by calling get CPU time, or alternatively get time. I'm in a package variable. And then when I need the elapsed time, it calls get time again, subtracts the last timing, does some other stuff to avoid negatives. Anyway, I can easily compute elapsed time down to the 100th of a second. And you can even use sys timestamp and get it down to 1,000th of a second. All right, so this, I write a lot of scripts like this. You'll find many of them are .tst files, test files for performance tests. And it allows me to very easily start the timer, run my code, show the elapsed time without having to do a lot of work myself. So let's compile this. Did that work? I hope it worked. Let's see. I'm still sort of new with SQL Developer, and sometimes I'm not clear about the messages that come through. Okay, compiled. Now we need to run it. Oops. Where are you? Okay, we'll just grab this right here. Not sure why I commented it all out. So I'm going to run my script 100,000 times. It'll query those 3 different ways, the same data over and over again. Run my script. Should take about 5 seconds. And here are my results. Executing the query every time, 4.6 seconds. Again, right up against that 5-minute mark. Caching the table in PGA memory, 0.05 seconds. Amazing. 100 times faster. Oracle 11G result cache, 0.1 seconds. Well, it's not as fast as the PGA cache. It's half as fast. So that's bad, I guess. But it sure is a lot faster than executing the query every time. And again, to go back and make this point really clear, I can use this. I'll connect to the database. We don't scale up. It doesn't have to be a static table. This table can change now and then. We just don't want it to change too often. And we get this incredible boost in performance. So hopefully that was very compelling. All I did was change the way I wrote my code to access the data. I didn't change the table. I didn't create a materialized view. I didn't do any of that stuff. I simply told Oracle, this describes the result cache is an accurate description of this function. In other words, it's using data sets which are not changing that quickly and should have static data for a period of time. So use that information when you set up my runtime environment. And then I let Oracle do all the work for me. Yummy. That's the way to do it. Let Oracle do all the work for you. And now if my PowerPoint would just come back. What's going on? Okay, so the function result cache, way, way faster than executing the query every time. And that's even for a highly optimized query. So in this case, I wasn't changing the data. The data was sitting inside the SGA. The cursor was certainly already parsed. What you're seeing is simply the raw power of avoiding the SQL layer. When you use the SQL layer, you've got to basically do a lot of handshakes. Hi, I've got a SQL statement. Did you already parse this? Yes. Hi, I need this data. Do you already have it? Yes. You avoid all of that with the function result cache. Okay, well, gee, that's really amazing. You say to yourself, I'm going to use this all over the place. Well, there's a lot of things to keep in mind about this feature. The first one generally is that you're affecting the way that memory is managed inside the SGA. You're affecting the delivery of data to your users. You need to use this feature with great care, and you need to closely collaborate with your DBAs, and we'll get into all of these details coming along. Now, first of all, you should basically just expect, but you should verify, trust but verify, that Oracle does the right thing. So, for example, what I've talked about so far is that if a user changes one of the tables on which a cache is dependent and then commits the changes, the cache is invalidated for everyone, and then it starts being rebuilt. What if you've made uncommitted changes in your session but not committed them yet? Well, in that case, the cache should be okay for everybody but you, and that's how Oracle does things. So dependent caches are marked invalid for you, they're ignored for you. And then when you commit or roll back your changes, then the cache will either be rebuilt or the cache will be made re-available to you. Okay? So the cache will not override your current partially changed data structures. As you might expect, caching is not performed for all sorts of complex types. If I have a parameter whose input has an input, if I have a function with a parameter of type clob or collections or object types, then Oracle's not going to do caching. And the basic thing to keep in mind is that it's basically building a unique index around your in-parameter values, and it needs to do equality comparisons. If it's not able to do that equality comparison, it can't help you. And I say, but Oracle's optimistic. I'll show you what I mean by that in just a moment. Another thing to keep in mind about this feature is that it's not related in your function. The cache is not. In other words, that doesn't execute any SQL statements and simply has some configuration values for the application. The main thing is that it's not changing every time the function is called. So I might use the function result cache for that as well. All the result cache feature knows about are the in values and the return data. It doesn't know what's going on inside your function, and it doesn't really care. It just will do what you're asking it to do. Let's take a look at some of these aspects. So back to my demo script. I'm not going to run all these different things. You can verify that it'll cache an entire collection of strings, collections of records. You can run all of this code yourself, and I encourage you to. Let's take a look at my script for making sure that dirty data is not available to our users. Now, that'd be really good. Let's clear this out. So in this case, in this script, I've got my cache on my last name function. I'm going to call it twice for 144. So we'd expect to see it execute the body of the function this time, but not this time. Then I'm going to update the table. And we'll see after that if caching is turned on or not. Then I'll commit. We'll check again. And then just go back to the way it was before. Okay. Run my script. Okay. The first time I called the function for 144, it executed the body. The second time, it didn't. Then I made a change. And now notice, every time I call the function, it executes the body. The caching is disabled because I've got an outstanding change. After I commit, we're back to calling the function the first time, executing the function, and then not executing the body the second time. So Oracle does the right thing. It will not allow you to look at that dirty data in the cache. In terms of Oracle being optimistic and restrictions on what you can define in your as a result cache function, let's just grab this package spec. And let's just change this to be of type club. Compile. And I get an error message. And it says, implementation restriction. Result cache is disallowed on subprograms of type club. But notice, may be temporary. I love this. May be temporary. So we're giving you the feeling that maybe in some way we'll be able to fix this later on, which is very nice. We need to be careful about raising our expectations, but I'm glad to see that we're thinking about it. So for example, at some point we might actually implement runtime comparisons of clubs. Probably never blobs, but maybe clubs. And so we'd be able to remove this restriction. More things to keep in mind. So you cannot use the result cache with invoker rights program until 12.1, which is probably not a big deal to most of you since you probably don't even use the invoker rights approach, but I'll show you briefly what that's all about. Starting with 12.1, essentially what Oracle does is add to your parameter list the name of the currently connected schema. And that way it creates a unique index and you get the function result cache effect. You might not want to use it, but there it is. Second, more generally and most importantly, functions that have session-specific dependencies should be result cached with great care. And we'll take a look at virtual private database configurations to drive that point home, but I'll also mention a simpler example of sysstate. So let's take a look at, first of all, the simple example with sysstate. Let's go back into this function. My original function. It's around there somewhere. And let's add up something to the where clause. And hire date is less than sysstate. Now, when I call this function for employee ID 100, if it's not in the cache, Oracle executes the query, makes sure that the hire date criteria is satisfied, and then returns the last name for that person. The next time I or anybody else comes along and calls last name for employee ID 100, Oracle says, hey, I'm done. I don't need to execute the body. I'll just return the value of the last name. And notice, it never invokes the select statement, and therefore it never checks the new sysstate. If you have a query inside your function that you want to result cache that has a reference to sysstate, it's probably a really bad idea for a result cache. Now, you could fix the problem in the following sense. What I could do is add the date to the top. I could only type. And I could put date in here. Now, every time I call the function, even if I don't provide a date, it'll use sysstate, and it will check to see if anybody's called the last name with 100, and that's the state value, and if not, it will execute the body of the function. It will use the criteria properly. There, I fixed the problem, right? So I found a session dependency. I moved it up to the parameter list level to expose it as part of the unique index for the function result cache, and therefore I've got a great usage of the function result cache, right? No, no, no. You have to think about what the impact is of the changes you make and whether it still makes sense. How often am I going to get a match on employee ID 100 and syssdate 2 seconds after, 10 minutes after the 10th hour today? Never. So essentially what you're going to do is fill up the cache with lots of data that will never be fetched out of that result cache. You use a lot of memory to no good effect. So this is the general path by which you get around the problem. In other words, you found an internalized dependency. You move it up to the parameter list, and then you've got uniqueness. But then you have to ask yourself, is this really what I want to do? Here's an example that would make a little bit more sense and is really exactly what Oracle did with the invoker rights. Let's suppose that user name. Let's suppose that my employees table also has the name of the schema associated with it. And this used to be equal user. So clearly, every time this function is called by somebody with a different username, again, with the function result cache, we will avoid executing the function body. We will not execute this where clause. We will have a problem. But in this case, I could put user in up here. Varchar2, of course, default user. And now, every time this function is called, and I don't pass a username, or I pass a username or use the default value, then Oracle can basically say whether or not anybody's called for employee 100, username XYZ. And then it might make sense to use as a cache. What you've essentially done is partition your cache by username. So in this case, the function result cache would only make sense if the same user connected to the same schema name is requesting the same rows over and over again. If you get duplicate requests for the same rows but only among different sessions and different schema names, this will not be an effective use of the function result cache either. So it's really critical to keep in mind how the function result cache works and map that to your specific requirements. With the auth ID approach, let's see. Oops, I'm getting there. It's hard to remember all the names of my files. Now, with invoker rights, just to cover that briefly, you see an invoker rights program when you see the auth ID clause that doesn't have definer, which is the default. So if you don't have any auth ID clause, it's auth ID definer. But instead you see auth ID current user. And what this means is that when you execute proc3, so sorry to step back, I create proc3, I own it, I'm Scott. I let everybody, including HR, execute it. When HR calls my program, and it's an auth ID current user program, then the runtime engine says, I don't care what emp was to Scott. What I care is what does that mean to HR. It essentially re-evaluates all references to database objects at runtime. And essentially that's determined by the username, the schema name. So you can see why, again, this would be a problem from a function result cache approach. If I pass in a parameter value and it's already been called, then the function body is not executed. The SQL statement is not executed. Therefore, emp is not reevaluated according to what it means to HR as opposed to Scott. So what Oracle did was, behind the scenes, move the name of the schema to the parameter list of every function that's marked as a result cache and is using auth ID current user. Again, you have to decide whether or not a per user partition of that cache makes sense, but at least now it's not rejected out of hand. Now, a much more complex scenario, and I'm not going to get into it in this class because it's just too complex, probably not anything you'll ever use, but a great example of both powerful features of Oracle Database and the complexities of the result cache, and that's VPD. So let me just briefly talk about it. I'll show you the scripts. And again, this is all available to you. You can try this stuff out yourself. VPD, Virtual Private Database, otherwise known as row-level security, allows you to create security policies on tables so that when any user says, for example, select star from patients, they want to see all the patient information in the database, then Oracle will wake up and automatically add a where clause to that select statement that might say, well, select star from patients where patient ID equals X. You can only see your own patient information, and so on. And the way that happens is that you create security policies. So for example, this security policy is really simple. It says when you're connected as HR, then add the where clause predicate 1 equals 1. If you're not HR, add 1 equals 2. In other words, if you're not HR, you get to see no information. But if you are HR, you can see everything. Obviously, most policies are much more complex than this and involve application context, calls to sys_context. But as you can see, I have a dependency on the schema name here. So if I make a function result cache, and this is part of my, and it's against the table upon which the security policy is defined, unless I execute the select statement, Oracle will not add where 1 equals 1 or 1 equals 2. The solution is the same. You identify all the dependencies inside your policy. You move them out to the parameter list. So here's my user N and my employee ID. And then you're partitioning by the schema name or by whatever the application context values are that you're using for your security policy. So you can use VPD. The bottom line is you can use VPD with the function result cache, but you need to do it extremely carefully or you could run into big, big problems. Managing the result cache. So as with any other significant feature certainly present in the SGA, Oracle offers the full set of toggles and switches. First of all, most importantly, the initialization parameter. You need to work with your DBA to size the result cache properly. If it's too small and you're starting to push data out of your result cache, well, that's pretty much negating the point of the cache. So it needs to be sized properly. There's a DBMS package for managing the result caches that's by default available to DBAs only. $views so you can see how things are going. And you can actually query the contents of the $views to find out what dependencies you've got. Let's take a look at that. Oops. So I'm not going to run all this code now. We're running out of time. I want to make sure we have some time for questions. But essentially, I can query against my $dependencies list and the objects that are cached. and I can show what dependencies I have for a given cache. Let's compile this. Table of view does not exist. It looks like I have to set up my access to the $sign view, so I will not run this right now. My apologies, but I will set that up in my schema for the next one. So we can access the dependency information. And before I move on, I just really want to focus on this topic one more time. When it comes to using the result cache, the key thing you need to do is identify, first of all, make sure you're on Enterprise Edition. Identify a set of tables upon which the function result cache might make sense. In other words, does the table remain static for a significant period of time? During that time, are many rows queried repeatedly without being changed? And then you go to your DBA and say, here are the tables I want to put the result cache feature around. Here are my functions. Let's do some sizing analysis. Let's talk about what's possible. Because it's not just a matter of sizing. You can also run into latch issues. You can't just willy-nilly make a change to a feature in the database and not assume that it's going to have a ripple effect. You should assume that everything you do could have a ripple effect, either in an individual session, for example, using too much PGA memory, or a wider effect inside the database. Collaborate closely with your DBAs. That's the path to a successful application. So in 11.2, there were two major enhancements made to the function result cache feature. One of them, as I already mentioned, is that you no longer have to say relies on. Oracle automatically figures out what tables your function relies on, which is great. The second thing that happened is that Oracle implemented fine-grained dependencies in 11.2. What this means is that every time you call a result cache function, it not only records the new cached information if it's not already in there, but it also keeps track of the list of specific tables that were referenced for that result. For example, you might have a conditional statement that if such and such is true, execute this select statement, otherwise execute that select statement, and it varies. And the tables that it queries from varies. You might use dynamic SQL. Prior to 11.2 and 11.1, if you made a change to any of the tables that a cache relied on, the entire cache was invalidated. Now Oracle is much more specific about what's been rejected. No longer all or nothing. Whoops. Let's pull it back up. Now my apologies, I had to show FRC dependencies, so we're not going to be able to see that. But run the script on your own when you've got the privileges set up. And what you'll find is that in this table, for example, I'm using dynamic SQL. So I pass in the suffix. I'm either going against pilch A or pilch B. So clearly, depending on the value I pass in, I'm querying from different tables. And the result cache now keeps track of that specific information. So when I update pilch A, the result cache rows that were entered for B remain intact. Only the result cache entries that depended on A are removed. Nice little feature, fine-tuning the behavior or the utilization of memory inside your result cache and maximizing the possibility for performance improvements. So make it easy on yourself. Hopefully you'd agree. This result cache is a great feature, incredible performance benefits when used appropriately. So how easy will it be for you to apply it? If you take the path that I mentioned earlier, and I think is the standard approach for most PL SQL developers, and you write queries anywhere you need them all throughout your code, in other words, you do not encapsulate your data access. If you write and duplicate queries, it's going to be very hard to do that upgrading. If you hide your queries behind functions, you have a single point of definition of that query, and you can upgrade instantly. Let me show you what I mean. So here's my do stuff with employees procedure. It is what I would call a high-level application program. It's not a generic error logger, string parser, etc. It's interacting with the database objects and the business rules of your application. I pass in an employee ID. First, I get all the information for that employee. I do a bunch of stuff. Then I get all the information for the manager. And notice, it's the same select statement. Now, these are both in the same program, but this is the sort of select statement that you're going to have all over the place. It's so easy to write. PL SQL makes it so easy to write SQL, and that is the danger. So let's take a look at what it would mean if we wrote code like this with the same select statement in 25 different programs, who knows where, and then you upgrade to 11.2 or 12.1 and you say, wow, function result cache, that's so cool, I want to use it. Oh no, I've got these selects all over the place. I don't have a single function I can attach the result cache to. What can I do? Well, first of all, what you can do is simply add a hint. I can specify that an individual select statement should be treated as a result cache. Think about it. What's the difference between a function and a query? With a query, I've got bind variables, you can't have out parameters, and I'm returning data in my into clause. It's really the same as a function. So if you do add this hint, then Oracle will treat this like it does a function. It will, whenever this query is executed, will check for the input value, the bind variable. If it's the same, it will pass back the result cache information. That's nice, but a lot nicer. But still you have to go and make this change everywhere the query exists. And how do you even know when you found them? At a minimum, it's an expensive operation, changing dozens, maybe 30, 40, 50 different programs in production. That's very expensive. Managers do not like that. Here's the approach I take. Whenever I need to get a row of data, I do not write a select statement. I create a function if it doesn't already exist inside a package, and I group them together by database entity, sometimes business entities. So give me one row for the employee table. There's my select statement. And then I call that, so now to go back up here, I call that instead of writing the select statement. Package one row, emp ID, etc. There are a number of benefits here. One of them, as I'm going to show you, we can upgrade more easily. The second of all, my gosh, just raw productivity. In 30 seconds, I can type that one line instead of, I don't know, a couple of minutes, making mistakes, copy, pasting, who knows what. Just call a function. Hide your SQL statements. And the real big advantage is that once I've done that, all I do, so here's my call to my different functions, all I have to do is add result cache keyword in one place. So really probably the best motivating way to think about the situation is that if you want to be the person on your team who is seen as the senior developer, who gets the promotions, who gets the raises, what you need to do is hide stuff away. Don't expose this logic over and over again all over your code. And this is true for business rules, for hard-coded literals, but especially for SQL statements. Hide things behind package APIs. Call your package APIs. That way you've got things defined in one place. And then you can add functionality to that one place, and wow, faster than anybody else, you've implemented major improvements in your application. Your manager thinks you're amazing, and you get the promotion. How's that for a motivation for caching? And caching the right way. So, conclusions. Oracle offers a lot of different ways to cache data. A lot of it's built into the SGA, and we just benefit from it. And boy, am I glad that I don't have to write the code to implement the SGA. Talk about complex, high-performance requirements. So one of the features you can rely on is certainly the deterministic keyword. Now, you're not going to have an enormous impact on performance, partly because the scope of caching is so narrow. But I would still suggest that you get in the habit of identifying code that is deterministic and adding that keyword to self-document, that's the intention of this code, it should not be changed. Identifying code that you can test more thoroughly, and also potentially giving the compiler and the runtime engines more information for, hopefully, possible optimization. PGA caching, incredibly powerful technique, applicability, however. And really, once you get up to 11.1 and higher, I can't imagine that you'd ever use PGA caching for runtime query behavior. You might still want to use this feature, however, when you're running a big batch process. So let's say I've got one job that wakes up Saturday mornings at 9, runs for a couple of hours, and it queries all this information out of the database, and since it's a reporting program, from the time it starts at 10 until the time it ends at 12, even if people make changes to the data, you don't want to see those changes. You want consistency. Well, Oracle will give you that consistency. You open a cursor and keep it open. And as changes are made to those tables, you keep a snapshot of what it looked like before. But that can be expensive in terms of memory. You can run into snapshots to old errors, and it can be relevant. In that kind of scenario, perfect application for PGA caching. It's just one job, one process. You don't have to worry about scaling. So you can pull all the data out at 10 o'clock in the morning, drop it into collections, using bulk collect, that's very fast, and then run your reports off of the collections. And you will see an enormous boost in performance. You automatically get consistency because you got a snapshot of the data at 10 o'clock. But on a day-to-day, program-to-program basis, if you're looking for a way to apply result caching to avoid querying the same row more than once when the data that you're returning hasn't changed, then without a doubt, function result cache is the way to go. It is the most declarative, and that's something you always want to look for. Choose the highest level declarative approach to telling Oracle how to get the job done. Sorry, telling Oracle what you want done, not how to get the job done. Really, it's the same approach. It will be most widely useful, even for non-static data sets. And the key thing is that even if you're not doing it yet, you may just be planning on doing it. Get ready for it now by hiding those queries inside functions. Never write those selects in the application code itself. Put them in separate packages, and you'll get an incredible boost in productivity, maintainability, and with the result cache, performance. So thanks for joining me. I hope that you learned an awful lot about the function result cache and are very well positioned to apply it in your application in a smart, collaborative way. Remember, talk to your DBA. Figure out what the maximum size is, how many functions you can put the result cache on. Okay, well that uses up my hour very nicely, I must say. Let's see if we have any questions. So you can type a question into the question box or into the chat window, and I've got some questions here to start going through. So feel free to add to them. In your collection example, doesn't the initial load cost more than the savings since the collection is session? Excellent question. Let's go back to the code. Let's look at my employee lookup package. In fact, let me just close all these out. So emp lookup. What am I doing? I don't want to do that. Okay. Emp lookup. So the question was, you've got this nice technique, Stephen. You're going to load the cache. You're going to load this entire table into memory, and then you're going to return data from it. Won't that slow down or negate the effect of the PGA caching? Well, it'll certainly have an impact. But as you saw from the results I showed you, not much. So here's some of the kind of results you'll see. This 0.22 seconds includes the loading of my table into memory. Now, it was just 107 rows, obviously not critical. But if you did have a very large table and you wanted to do PGA caching, you would not do this, for sure. What you would do instead is just-in-time or incremental caching. So, for example, pass in the employee ID. If that employee ID is inside my cache already, grab it and return it. If it's not inside my cache, get it out and put it in the cache. And by the way, if the collection gets too big, delete it and restart. So this is an example of programmatic just-in-time caching that mimics what the function result cache does. So if your table is very large, let's say your materialized view has 10 million rows, you're not going to load it all into memory. That's a very good point. You will do it incrementally, as needed. Excellent question. Let's check out some others. Do you need to also set the result cache annotation on the tables you will be using in your functions? There is a syntax called alter table. Let's see if I can pull it out for you. Whoops. No. So the syntax is alter table, table name, result cache force. You can essentially force a table to be cached, and it's something you consider doing. I would not do it in a production application. I think you want something that's more fine-grained, that you have more control over. Let's see, there's a question that says, in Apex, do you need to base all forms, reports, charts on procedures rather than directly on tables and views? Well, actually, in my understanding of Apex, and I'm not an expert, you cannot create reports and so on procedure calls. You can only create them on select statements. But you can select from a table function. Let's show you what I mean by that. Let's see. Let's see, a table function is a function that you can call on the where clause. Sorry, I just need to arrange things a little bit here. Here's an example of calling a table function. So select from table of, and then you can call a function, and basically inside your function programmatically construct a data set. So in Apex, what you could do is build a query, a report, around a table function, and effectively move the complex logic for creating your data set inside that function. But I don't think you can build it off procedures. Okay, let's keep going. I've got a lot of questions here. Does your demo zip include code that we can run to monitor SGA and PGA so that we don't have a runaway result cache function? My demo zip does not include code to monitor SGA stuff because that's DBA related, but on the PGA side, absolutely. So let's take a look at memory package. So the PL/SQL memory package calculates and shows UGA and PGA memory consumption. You have to have grants on these three $$ views, so you have to go to your DBA for that, and then essentially it just hides queries against the $$ views to retrieve the PGA memory. So absolutely, in my demo zip, download and install the PL/SQL memory package, and then you will be able to analyze PGA consumption in your session. In terms of SGA consumption, that's something you'll need to check out separately. What was the path to OLL for your source code? Okay, so if you want to get to my source code, and I encourage you all to do so, let's go out to Safari. What you do is go to oracle.com/OLL, Oracle Learning Library, and then type in PLSQL, and then you'll see PL/SQL Learning Library. And in the Learning Library, demo zip. How do you minimize latches when using the result cache? Great question. Honestly, it's not my strong suit around the result cache because it's more database administration related, and I don't have a good answer for you on that one. I suggest that you do some searching around latches and the result cache. Where can I get a copy of the PowerPoint? So I just went through the access to the OLL. You can download the demo zip. You'll also have access soon to a recording of this presentation, and we'll make the PowerPoint available here as well. And we'll send out information. I think ODTUG will let you all know about the location of the video. Can we use the result cache in Oracle Forms? Absolutely. The result cache is lower than your application development code. So whether it's Java, Oracle Forms, Apex, JavaScript, etc., this is built into the database layer. And so any program that, or any application that calls those functions will be able to take advantage. If we have automatic memory management turned on, do we need to apply values in the function memory values? Well, I've got to tell you, I don't really here's another version of it. Do we need to apply values in the function memory values? So I don't know too much about the database automatic memory management features, but I'm pretty sure that it's independent of the function result cache. Question, do I think that the result cache will be available in standard edition sometime, eventually? Well, let's see, as an Oracle employee, the answer to that question is, sorry, cannot. I have not heard anything about that change, but I'm sure you all know if you've been around Oracle for a while, that Oracle will ask for additional payments for various features, and usually eventually it gets rolled into the non-extra fee area of the database. I'm not sure about the result cache. Certainly at this point, you do need extended edition. I see a message here saying Oracle Forms 11G does not compile when invoking any function using result cache. Okay, sorry, I was not aware of that. I don't know why that would be the case. I can certainly see that you couldn't create a function inside Oracle Forms that used the result cache, but I don't know why 11G Oracle Forms would be a problem with that. How would I say function result cache is applicable in Apex applications? Again, regardless of your front end, Apex, Oracle Forms, JavaScript, etc., the function result cache is a matter of you identifying how the data in those tables are used. If the data changes very frequently, every second, every 5 seconds, a change is being made and committed to that table, you do not want to result cache it. It doesn't matter where you're calling that function, whether it's Apex, JavaScript, Java. What matters is what's the behavior on that table. So I don't see why FRC, function result cache, shouldn't be perfectly applicable in Apex applications. Can I use a result cache on a table and a join? I assume you're talking about the hint select with the result cache hint. With a join, as far as I know, you will be able to do that, yes, and it will basically list all the tables in the join as relies on. How should the DBA compute the result cache size? I don't think there's any particular formula to follow. I believe that what you need to do is set up the function result cache on several functions, run them with some close proximity of production behavior, and get a sense of how much memory is being used. In the example of the deterministic function with sysstate, could trunk of sysstate in the default value be used to make good use of the cache? Good point. So let's go back over to my code. I think I lost that example, so let's pull it back up. So the question was, if I add this and hire date is less than sysstate, what if I change it to date in? And then do this in date and default trunk of sysstate. And the answer is certainly this will improve the likelihood that you will reuse the data because you're working with just the date component, not the time component. But the question really there is, what makes sense for your application? If you don't care about the seconds and it's just down to the day, then you're good. So that's an application-specific question, but certainly it's a good example of how you can make some extra effort to improve the applicability of the feature. So a table with state codes, for example, O is for open, C is for closed, etc., do not change frequently at all. Are those good for result caching? Yes, I would say that that's the classic example of a table that would be a good option. Let's in fact look at some tables. These are the tables for the PL SQL Challenge backend. And I have a number of different types tables, like competition types. We look at the data, and there are 10 rows. You've got polls, competitions, studies, playoffs, etc. This table changes very infrequently. So this would be a great candidate for the function result cache, a function on top of this table. If your query returns far more data that can fit in the result cache, is there still any benefit in using it? I would say that if you have a single query that you're putting a function around that returns a collection with so much data in it that it's going to fill up your result cache, then you need to rethink how you're using the result cache. Usually you're not going to want to cache tens of thousands of rows in a single query unless that particular retrieval of that data set of 10,000 rows is going to be used in multiple places, which seems kind of unlikely. So I would say that you need to size your result cache properly. You're mostly going to be talking about retrieving data from single rows or small number of rows. And if you're looking at any single function result cache that is likely to overwhelm your cache, you've probably made a bad choice in result caching it. Okay, excellent questions. Thanks for staying on to listen to my answers. Hopefully they were satisfactory to you. Now again, I simply suggest that you make your way over to the Oracle Learning Library, drill down into the PL SQL Learning Library. If you haven't already gotten my demo zip, grab it, take a look at all the other resources, my other webinars, and make the most that you can of all the resources you've got to improve your PL SQL performance and maintainability. So thanks for joining me, and I look forward to seeing you at some event in the future, and hopefully you'll attend my future webinars. Check odtug.com for more information. Thanks, everybody.